Hi, my name is Miles Bromfield, and today we're going to be talking about pump failures and how they correlate to poor system design. Pump failures out in the field are challenging to avoid, but most can be mitigated by making sure we have a properly designed system that matches the applications in which these pumps are used. Before we can diagnose what is wrong with the system, we first need to diagnose what failed inside the pump. The only way to do that is to look inside the pump and check each individual component for wear and damage. In front of me here, we have a 45cc axial piston pump that failed out in the field. Let's take it apart and see what we find. Taking apart a pump can be a messy job. You want to make sure you have a few hydraulic absorption pads laid out on your workstation as a means to drain any excess oil. Safety always comes first, so make sure you have the proper PPE and that you are following all safety protocol. As for tools, be sure to have a set of Allen keys and a clamp. Now that we have this pump disassembled, we'll look at each individual component and note the level of wear we see. This will not only tell us how the pump failed, but why. When we look at this pump, we notice that the most significant damage is dealt to the distributor plate, the pistons, piston shoes, retaining ball, and the retainer plate. As you can see, there is damage to these components. But what does this tell us about our system? Let's start with the distributor plate. Notice that one side of our distributor plate has more wear than the other side. This occurs when the pistons lift off on the suction side and resume contact on the distributor plate on the pressure side. Liftoff happens when we have a high pressure differential between our K-strain and our suction lines. To help remedy this type of pump failure, it's best to confirm proper hose sizing and make sure your inlet conditions are ideal. The next two pieces we want to look at are the pistons and the piston shoes. When we look at the face of the shoes, notice scoring and deep grooves. The grooves tell us that there is contamination in our fluid. The additional scoring is a sign of cavitation. When we look at the piston, you'll notice there is rounding on the edges of the slipper pad. This is a result of liftoff mentioned previously. We also noted imprints in the retaining ball left by the pressure pins. When we look at the contact surface of the retaining plate, we see signs of seizing where the ball was jammed into the retaining plate. This is a result of the poor suction and K-strain conditions. What did we learn about our system from the component failures? We learned that inlet conditions and pressure differential are far from desirable for this application. The best way to avoid these failures is to ensure that our sizing and calculations are adequate for our system. We also learned that we should always be checking our hydraulic fluid to ensure that it is kept clean and free of air and contaminants. On behalf of myself, Spencer, and the rest of the GCC and EOHI family, we thank you for watching this video, and we hope this helps reduce the number of pump failures that you see out in the field.